we need to know definition, elasticity. Elasticity is a property of the material enable the object to return to the original shape or size after the force. 只要那个东西你拉了放回去，或者是你压扁它，你的 force 拿走 the object can go back to the original shape, then we call it as an elasticity object. 因为那个 object 是 elastic 的。This one definition, the definition is quite long, so to remember. I see the diagram. Solid is elastic. Solid elastic. Example, rubber band. Rubber band is one of the example, or you say spring. When you just pull 拉长, they pull longer, stretching. You find it inside the molecule. The molecule, what happened? The molecule want to go back, is it? Because you're stretching, the molecule want to come back. From here, they say two forces between the molecule and also the atom in the solid. There's an attraction force. 我拉长它，它一定有它的 force， 因为还要 pull back 嘛，还要回来嘛，这个 attraction force. From here, you can see this one is an attraction force. 它要自己拉回来。Okay, if I go to compress, 我去压它 ，there's sure got force for the atom. There's a repulsion force. 它要推回出去。This one is normally the forces acting for the atom. When you do the action, pulling or stretching, then or you say compress. The molecule, they got certain of the forces, they want to go back to the original size. This has two forces. Now see the diagram, attraction force. The spring, I go to put the ball here. Then you find the spring become longer already. When I put another ball, heavier ball, you find it extends some more. This one they produce is an attraction force. Then they want to attract and go back to the original size. They want to push to each other. After that, they want to pull back the spring. From here, we go to explain. The molecule are slightly displaced away from another. 跑位了，拉走了。The strong attractive force. 还有一个很 strong 的 attractive force want to pull back. Between the molecule to oppose the stretching. You are stretching, I don't want stretching. I want oppose. I want to come back. When the external force just remove, now the attractive intermolecule forces bring back the molecule back to the equilibrium and come back to the original location. From here, the wire return to the original position. This is how the molecule, how the atom function when you just pull the elastic object. You must remember what is a force, what is attractive force. You say attraction force, and another one is a repulsion force. Repulsion force is when I go to compress. Okay, you see the spring is longer, is it? I use the box, I go to push it. When I just push, then you find the spring, what happened? The spring also want to go back to the original. From here, they got repulsion. Repulsion 就是还要推回出来。Repulsion force. From here, we still explain the same thing. Compressing a solid causes the molecule to be displaced closer. Just now is stretching. Stretching is further. Now I go to compress, you find the molecule become closer. What happened? Repulsive intermolecule force push the molecule back to the original position. Just now is attraction. Now is a repulsive. Next, this one is a two situation when you're stretching, when you go to compress. What happened for the molecule? This is one of the experiments. Have you done before? Before the holiday, have you do any experiment about the spring? 有吗 ？Hello， 好像有是吗
？Spring 啊，
拉长的 spring 和它的 extension。
有一个它那边是拉很长，然后会变回那些就有。可是如果认真做这种像第5个这样的那 experiment 就没有。
I mean, you never measure the extension is how many lah. This is one of the experiments when you come to school need to do, must do. This is a wajib. This one is one of the experiment they want to find a relationship between the force and also extension. Then you know law for common sense. When my force is longer, sure extension is longer law. This one is a directly proportional one. From here, the experiment just like this only. Put a spring. Before extend, you need to measure first. Measure original line. Put the ruler here, then you measure what is the length for the original before you put the load. When you put the load ready, example, before I put LO 15 cm, then I put 20 gram. Then when I put 20 gram, they become 20 cm. The question want you to find extension. The extension is the 5. If I continue, L2, I put 40 gram. 40 gram become 24. From here, you need to find the extension from the 2 and 1, not 1 to 2. You take 24 minus 15. This one baru is your new extension. So your extension will become bigger and bigger. 不是2跟1相比永远跟 original 比看你长了多少。After that, your number should be bigger and bigger when I put the load is heavier lah. From here, this experiment, later you find you need to plot the graph, force versus extension. Extension cm and the force is a Newton. I mean, normally the experiment we're using gram, is it? Gram convert to force. If the gram convert to force, better we're using the G is a 10 is simple. Why? 20 gram 要 G， 你除1000 so you divide by 1000 and then you become the G. From the kg, you want to go Newton, you multiply G, is it? G normally 9.81 if I'm using 10 simple 咯，容易咯，除1000再乘以10，所以其实是除100罢了。When the gram you want to convert to Newton, actually just divide by 100. Because you divide by 1000, you become kg. After kg, you convert to Newton, you multiply G. I think the G is a 10 because simple for calculation. Finally, you only divide by 100. From here, force, then versus extension, I get it directly proportional. 你的 graph 肯定是 straight line. Maybe we do experiment, they got some of the mistake, we cannot start from the 0. Some they draw increase linearly like this. You draw your perfect one, perfect graph. Cannot touch the origin, but you can touch more of the reading of that one is better. 如果你过不到最后一个0，但是你可以碰到很多点，也是可以画，也是代表你是 increased 的。The better one is this one, directly proportional. After that, when you draw 2 on the line, the others is a balance. This one is a Hooke's law. This one experiment we call Hooke's law. If I take out the directly proportional, F equal Kx. Suppose it's a F equal gradient, X, no C. 我们没有 C. Y equal mx plus C 是 general. For this one experiment, there's a F law. Then mx, x is an extension. Then we know C. Suppose it's a 0. M 是什么？ M 是 gradient. M is a gradient. But from here, they put K. 他们用 K. From here, if you want to find the K, you find the gradient. What's the later we learn what's the K. Now you see the extension of the spring increase in the length of the spring when the stretching force is applied. When you're just stretching more, they will increase more the length. From here, if you want to find the original length, you must mention first. After original length, you mention, then later your extension total length, you minus the ori, baru you know X. I think this one everybody know lah. Ori this one, then later you put become L1. You want to find extension, then you take L1 minus L0. Okay, this one is an extension, how to find. Hooke's law. Just now the experiment we call Hooke's law. Hooke's law state extension of the elastic substance, that means X, directly proportional to the stretching force, mean F. Okay? Only provided that the elastic limit is not exceeded. What's the meaning for elastic limit? 就是那个 spring 还没有坏，当你拉的时候 release 的时候它 go back. This situation we call elastic limit is not exceeded. If I pull, I release, it cannot go back already. Longer and longer and longer. As I mean, now the spring no function already. They're already over elastic limit. If they're over the elastic limit, when I plot the graph, when I started one, cantik one, very proportional. Suddenly, like this already. Like this already mean, your spring is no function already. Already over. This one called this point. When it just the point cannot go up, we call elastic limit. You already over the elastic limit. Now your spring no function. Cannot say your spring elasticity already. No more elasticity. No more elasticity, and also this part cannot say Hooke's law. The starting part of still Hooke's law, but this part no, because you're already over. From here, F equal Kx is a formula for the Hooke's law. It stands for acting force. The force you're acting. X is an extension. K is a spring constant. You also can say there's a gradient of F. versus spring constant. Another meaning is stiffer of the spring. 就是你的 spring 有多强。If I find the number K is very high, what's the meaning? The spring is very strong. If the spring very strong, that means easy to pull or not easy to pull. Right, Anna? Easy to pull or not easy to pull. If I say the spring constant is very high, no. I mean, you very hard to pull. Then I can say the spring now not elastic. Not elastic 就是不容易拉。Normally, this one where we are going to apply. We apply for the cradle. 小孩子睡觉那摇篮. Normally, we want high spring constant. If you put the elastic, you go to pull, then your baby hit the floor already. Normally, we need high spring constant. Make it more not so easy to pull the spring. Depend the situation. 有些 situation 我们需要 elastic, 有些我们不需要. You just remember spring constant, what's the meaning? Spring constant means the stiffness of the spring. If the spring is strong, that means the spring constant is high value. We're going to see this one. This one is a spring constant graph. F versus X. The formula is a F equal KX. You want to find the K, to find the gradient. The gradient here is a 20 over, how many? I don't take 20, I take this one at 15, because this one I don't know what's the reading. At 18 over 10. The answer is 1.5 Newton per cm. Depend the graph. So this one is my spring constant. A unit, suppose is a per meter. This one is a SI unit. You want to SI units, you convert 10 cm convert become meter, 15 over 1. The answer is 15 Newton per meter. SI unit. The spring constant K is a gradient of the graph. Gradient of the graph. You see now I got A, I got B. You tell me which one spring constant is bigger? Touching A and B. Which one spring constant is high? 哪一个？讲久 A. Why I say A? I see the gradient. A 跟 B 哪一个比较斜？ A 比较斜。When A the sliding is more, that means the gradient is bigger. Gradient is stand for A, now the big gradient compared to the B. I can say the spring constant for the A is bigger. A the spring 是比较硬 compared to the B spring. From here you can see larger value K, or you say gradient, there's a stiffer spring. A is a stiff spring, B is a soft one. We see the graph, then we know already. Some is the question they sengaja want to catch you. They put X here, then they put the F. Then like this, A and B. You tell me which one is a stronger spring? You see? 来，这个 diagram B 哪一个比较 strong？ 哪一个 spring？
这样多人可以问，可以不要问我吗？
这样多人就是没有反应，所以你
反过来嘛，那就是 B 了。
所以咯，我们要看清楚这个。Normally 是 F versus X. Sometimes the question the sengaja want to catch you, then terbalik. When terbalik already, then you understood. Now your K become what? 1 over gradient. 1 over gradient already. You want to choose the bigger K, and now it's a B already, not A already. Remember, must be careful when you see the graph. What versus to what? Finish the spring constant, then we're going to see elastic limit. Just now we got mentioned elastic limit. Elastic limit is one of the point when the spring over the maximum extension cannot extend or not extend, cannot go back to the original. From here, when starting, when I put the graph till A already is a maximum. When I continue to pull, they continue longer. Okay, you find it they continue longer, but the force is smaller and smaller. No more the pulling force already. You make it longer and longer, that means they're not straight line. Straight line means they still can go back original size. Although you find this point gradient, this point gradient, this point gradient, the spring constant is the same. But this point, the spring constant out already. Because not constant, the spring already spoiled. 不可以再用了。你怎样拉的话，它都是不能回去的，它只是越来越长。This one we call over elastic limit cannot obey Hooke's law. 不讲 Hooke's law. You also cannot using this formula. Cannot use when you just over elastic limit. But A we call it elastic limit the point. OA is what? OA still a Hooke's law. They say the graph is straight line passing through the origin. The stretching force is directly proportional to the extensions. This one is a Hooke's law obey for the starting part. How about the AB? AB means already over the elastic limit. The graph that take form is a curve. Line macam curve. There's a stretching force is not valid directly. No directly with the extension already. Now we can say the Hooke's law is not applied. When you just over, we cannot apply the Hooke's law already. That one means our elastic limit. You must know the graph for every part what's the meaning. O 什么意思 ？A 是什么意思 ？A B 是什么意思？你要懂。Until now already, any question you want to ask me? 有什么东西要问吗？问就开麦问，不要这样给博慢慢打字打到来明天都没打完了。Shermaine, go. Or anything want to ask? No. I want to continue number 9 already. We need to analyze the graph F against the extension. Just now show the graph already. Now we go to analyzing. Just now this is a normal graph. Force versus X already. You find the gradient, there's a spring constant. We continue. Introduce another energy. Potential energy, but they call elastic. Okay, before that you learn energy from your, you learn energy for Form 4 啦，有吗？Form 4学什么 energy？ 来定讲一下。Before you learn any energy you learn Form 4，就是没人讲话了。来，实际讲。What energy you learn before？
Elastic potential energy。
Form 4啦，不要讲这样简的先啦，讲普通的会动的，会动什么 energy？
会动的 kinetic energy 哦。
kinetic energy we learn before half mv squared， mv squared。什么？高高的 location high.
Potential energy.
Potential energy mgh. This one is what we learned before. Now we add one more. Apply for the elastic object. Something you can pull, then go back to the original. There's an elastic potential energy. This one formula is a half Fx. Half Fx, that means the force you go to apply. X is the extension. Just now we learned about the Hooke's law. If I want to find the K, I'm using F over X. From here, I also can be apply the F by using this formula. You can say half K squared also. If the question never provide the F, they provide the K. After that, I can guarantee the F using Kx. Depend on the situation. From here, that means elastic potential energy got two formula. For elastic potential energy EP. EP lah, EP also, but make sure you know elastic. Don't just mention potential energy. 你讲 potential energy, 我可以讲gravitational potential energy. 我也可以讲 elastic. 所以你要讲清楚什么 potential energy. Work done to stretching the spring. Average force multiply the stretching. And work done formula. Work done is a force multiply displacement. From here, I know I apply the force to pull the spring. The spring extend, the one is a distance. There's a force multiply displacement. From here, I'm using the formula. If I go graph, just now they say the graph gradient is K. But now I want to find another thing, area under the graph. How you find the area under the graph? You're using multiply this one, 长乘高 divide by 2. That one is the area under the graph for this triangle. Suppose this one is the elastic potential energy. Because just now we say half Fx. If a graph already, the question can find you K, you also can find elastic potential energy. K, you find gradient. Elastic potential energy, you find area under the graph. 一个 graph F versus X, 我们可以找两样东西。你可以找 gradient, 就是 spring constant. 你可以找 area under the graph, 它就是 elastic potential energy. The problem is energy. All must using joule, is it? Joule is the SI unit. 所以你的 X 一定要 mass meter. You need to convert. This one is the graph. What information can tell you? This one based on the graph. Area under the graph is the area of the right angle triangle. There's a half Fx. Half Fx is the elastic potential energy. This one is a formula. If you substitute with the Kx, we can apply this formula. 它的 question 给你还是给你 K， 给你 F 你就用这个，给你 K 你就用这个。找你的 elastic potential energy, make sure SI unit. 有问题吗？没有出神就是没有问题啊。See example 1. Spring R. For the diagram F versus X, versus X 呢，你就比较 safe 一点，你就不用倒反。 gradient 就是 K, area under the graph 就是 elastic potential energy. From here, the question want to find spring constant. They want to find spring constant. Spring constant means we find gradient law. From here, I gradient, and now give me the gradient. 8 gradient 不是 y over x 吗？ 8 divided by 0.2. y1 minus y2 over x1 minus x2. 看见打字不要开麦讲话了。Answer, take any one here, but normally we take the biggest one. 8 over meter already, Newton already, no need to change. You just take 8 over 0.2, you get it as a 14. What's a unit? Unit is a Newton per meter. Newton per meter, 8 divided by 0.2. Finish the first one. B, determine the elastic potential energy when the spring is stretching until 0.2. That means you need to focus 0.2. I do one 0.15, 0.1, and so on until 0.2. So find the area and area under the graph how many. So and I calculate again. 来算错，现在给我算好它。Find the elastic potential energy. Area under the graph. Area half multiply the height. Height how many? 8. 0.8. I get it 0.8 joule. This is my elastic potential energy for the spring. This one is for the spring R. Now you see the second example bottom here. Example 2 is a spring S. Now you compare a bit. Just now is still 0.2 meter, only 8 Newton. And this one you can see 0.2, I need to apply 16 Newton. 16 Newton. From here we compare which one spring is strong, which one spring is soft. We can compare by using spring constant. Again, find the spring constant. Find the spring constant, we take the biggest one. Spring constant K equals 16 over 0.2. Cindy, what's the answer? Cindy here now. E. 16 divided by 0.2. 80 Newton per meter. Spring constant is 80. Next one, elastic potential energy. Area under the graph when until 0.2. They want this one. Diane, do the calculation for me. Area under graph. How many? How many joule? Nobody here. In Zia, elastic potential energy, how many? 1.6. 1.6 joule. Now we do the compare. Spring S and spring R. Spring S, I find it 80 Newton per meter for the spring constant. R only is D. That means we find it the spring S is stronger one. We compare. 20 Newton, I want to put 0.2 meter, I only using 8 Newton. 只要8个Newton我一拉，它就会长到 0.2 meter。但是 Spring S， 你要它长到 0.2 meter， 我需要用到是16 Newton， 所以肯定这个是 strong 了。OK， 还要 double strong。That means spring constant sure we find the bigger value, that's 80. Elastic potential energy also increase. That means when your K increase, elastic potential energy also increase. From here, the solution we finish already for 2 example. The question we ask you, based on the answer in 2 and 3, compare the spring S and spring R, stiffness of the spring. Stiffness sure the spring stiffer than the spring. S 比较 strong, 比较 stiff. Elastic potential energy also same. Spring S bigger than spring. This one is a comparison. Any question? Anyway, now the last one is an important factor will affecting the stiffness of the spring. 什么东西弄到你的 spring 会比 strong 或者是比较 weak? Let's see the first one is a material. 不同的 material, 你的 spring 有不同的 spring constant. From here we find it, one using steel, another one using copper. Sure, the steel is a strong one. The steel more stiff, larger spring constant. Copper less. And copper is a low spring constant. That means the copper is a soft and easy to pull, but the steel is not easy to pull it. The first factor is the material of the spring. Let's see another factor. Another factor is the length of the spring. Shorter steel, longer steel. Shorter one is more stiff. 越短的 spring 越难拉，长 spring 比较容易拉。Now the material constant, both material constant. From here, larger spring, constant. Longer steel string, less stiff. Okay, low spring constant. 只要你越长，你的 spring 就比较容易拉；你越短比较难。This one becomes strong. This one is a soft. Number 2 is a length. Number 3 is the diameter of the spring. Diameter of the spring means the mouth, 嘴巴，那 coin 的嘴巴。Your spring is a bigger diameter one. That means that one is a larger spring constant. Okay, diameter steel, less. Okay, 越大越容易拉。This one hard. The mouth is very smaller. That means the diameter of the spring is smaller. The one is more stiff. Okay, if small stiff means the spring constant large. Let's see the D is the thickness of the spring. 两个嘴巴一样大了，现在 constant 了。But the thickness is different. Some wire is very thick, some is thinner. So from here we find it, very thick one means very hard. Diameter 越粗越难拉。So this one higher spring constant. If you find the steel spring, that means the wire become fine. So there's a less stiff K drop. Okay. So we got so many factors already. The first one is a material. Then the second one is a length. Then the third one is the diameter of the spring. D is the thickness of the spring. Last one, E. This one important because we got two calculations. Let's see arrangement series, arrangement parallel. Which one stronger? Sure, parallel. This one weak. When I just extend longer and longer, that means actually they never help anything. They just make the extension increase. If the cladle for the baby, you put series, your baby hit the floor. Normally we put by parallel. Parallel is more stiff. Larger spring constant. If series, less than spring constant, lower also. Now we're going to see how to do the calculation. If I say kg, then original is a 10 cm. When I put 2 kg, now become 12 cm. I can conclude 2 kg when I just put the extend how many? Extend 2 cm. From here, if I say like this, I got double, 2 kg. I want to see this one, double spring. I put series, 2 kg also. Okay, I want the answer from Teo Ho Wen. Can you tell me the total extension is how many for this one? Extension. Answer? Okay, nobody answer, then should we answer?
你不要这样嘛，
都不用回答，我要讲
比较大因为它会 double 嘛。
这是多少？
是多少先
？OK， 我越加多 spring series 的话，我们没有 share 的，每个人都一样掉2 kg 就对了。你 extend 2， 我也是 extend 2， so total extension 10 cm。如果 question 问你 what is the total length 你要加回 ori 10 cm 再加一个10 cm， 所以是4 cm 再加20 cm 这个叫做 total。 OK， 明白吗？
明白。
Series, that means we don't care lah. You just plus together. But parallel different. If parallel, that means, example, this one is an ori. Okay, extend to cm when 2 kg. Now I put C parallel. I put 2 kg. Is it the extension still 2 cm? Yes or no? Shermaine go. Is it still extend 2 cm? If parallel? No. So should be how many? 不是2 cm 应该是多少嘞 ？1， 因为它要 share 你多少 spring？ 如果我3条 spring 你这2 cm 就拿除3，就是2除3。如果我4条 spring 的话，2除4。Then you know what is the extension. I mean, if I got 2 spring, they say 1 cm only. The extension is 1 cm. If the question asks, what is the total length? What's the answer? Total length. Cindy, what is the total length for this one after put 2 kg? Original is 10, So the answer is 这个1 cm 左右要不要加起来？Total 10 only 我 extension 呢？我有一个 extension 呢。Then ori is a 10. Then your extension is 1 cm. So total length is a 10 plus 1. Yes, 11. 这个叫做 total length. Extension 1 cm. 记得 parallel 不需要左右加长度的，只需要一个 part 一个 side 加起来就可以了。Now we continue to see the bottom one. This one is just let you to know how to do the calculation. In series, you just multiply your how many spring more. Let's say extension is an x. If you're 3 spring, 3x. The next one, if parallel, you just divide by 2. Divide by 2. Now we can start this example. Let's see this example how to do. Information. Original length. We write first. Original length 5 cm. With the load of the 20 gram, the length of the spring extend to 7. Anybody can tell me extension how many? The extension is a 7 or extension is a 2. The extension is a 2 only. 7 minus 5 and 2 cm. From here A. The extension of the spring with the load 40, just now 20. 20 嘞就乘2 cm. Now 40. The simple one, you want to using the equal kx is okay. If you do one using the formula, you just write the ratio. 20 gram extension is a 2 cm. Yes. 40 gram, simple lah. Like just like this. 4 cm. Finish already. B, the length of the spring with 60 gram length. Define extension first. If 60 gram extension is how many? 6 cm long. But the length you must plus the ori. 6 plus ori is 5. Even C, the load they're required to put until the spring to 20 cm. That means the total length become 20 cm. You do know you want to put how many? I want total, the load don't know. Okay, now we're going to see how to do this one. 20 gram 2 cm. 10 gram is 1 cm. If I follow the range lah. Now 20 cm. Don't forget 20 cm is overall the length. I just want to know extension. I don't want to know overall the length. Extension how many? You take 20 minus ori. Original is how long? Original is 5 cm. After minus 5 cm, correct? After minus 5 cm, I get 15 cm is extension. 15是 extension 来的，因为20减了 original length 嘛。From here， 我要150的 cm。你认为这个要多少 gram 呢？一定是150 gram 咯。From here, the answer C is 150 gram. This one is the answer for the C, ABC. Next, question 4. Question 4, they give you the info. The spring extend 2 cm when it hung with the 10 gram. Spring A gram extend 2 cm. Spring B, different gram, extend 4 cm. They want to find total stretch on the each spring. Total stretching means extension, total extension for the stretching. Now we're going to see the diagram. 20 gram. Then just now they said 10 gram, is it? 20 gram means double. For the A, 10 gram, 2 cm. Now you got 20 gram means 4 cm. Next one, 10 gram. For the B, 4 cm. I got double. This one becomes cm. Answer A is 4 plus 8. Total stretching 12 cm. For the B is both also 两个都是 10 gram 2 cm for the A. This is for the B. Now I not take 50 gram. I need to sharing. You do first, you take 50 gram first. 50 gram extend times 5, 10 cm. But now I need to divide by 2 because I got 2 spring. Divide by 2, suppose is 5. So from here, B is 5 cm. C. Okay, combine. We do the A first. A 10 gram 2 cm, 40 gram, or then times 4, 8 cm. 2 times 4 cm. How about this one? B, sharing. If I share already, that means you get 20, I get 20 lah. 20 suppose is how many? 20 is 10 for 8 cm. Gram 4 cm. 20 gram 8 cm. And the next one, they ask you total stretching. 8 plus 8 咯, total stretching. 8 plus 8, that's a 16. 这三个有没有问题？声音有问题吗？这题
没有问题，都对。
那我都想睡觉了。
那结束哦。
没有啦，讲完 example 先。
OK， 我要做第5题，我要做这。
Original length, we write the info. Original length 12 cm. With the load 20 gram, the length of the string is extend 2. And now you tell me extension how many? 15呢还是3呢？3 not 15 3 Now what is the elastic potential energy? The question want to find elastic potential energy. Elastic potential energy is a half Fx. Okay, elastic potential energy. Now you need to convert gram become Newton. Remember, take the G is a 10, 20 gram, you convert to kg first. You divide by 1,000. After that, you get it 1, 2, 3, 0.02 kg. Convert to Newton. Multiply 10, if not 9.81. Multiply 10, that means the number quite jumped it a bit. We don't want to using the 9.81. But exam must using 9.81. From here, I get it is 0.2. 0.2 Newton. Apply this one in. EP equal half 0.2. Okay, then the x is a 3 cm, is it? 3 cm convert become meter. Convert become meter. I find it as a 0.03. The final answer, press your calculator, then you get it. Cindy, give me the answer. How many joule? How many joule? 0.03. So, how come? Half. Multiply 0.2. Multiply 0.03. More the value. The answer half. Multiply 0.03 divided by 2. 3 times 10 power of -3 joule. Or you write 0.000. This one's the answer. Number 6. 6 versus X. You save, we do the question. What is the potential energy stored in the spring with the extended until 0.4? Again, half Fx for elastic potential energy. The answer should be how many? Okay, 11, 快点，按一下。
是哦。
Then we go to 7. 7 is a compress the spring. You see what's the difference? From here, when I put the ball is a mass 10 gram, I push against one end of the spring. The smooth surface, the original line is a 14. After when I apply the spring constant 200, it becomes 4. K, this one question now they provide the K. Then they say the compression. Now your X is a 4 cm. That means apply force, depend your force, how many go to apply here. This one not force. I cannot say, 10 gram. I make it become mg. There's a force. No. Your force now is acting down. Your ball, the weight is acting down. The force is I pull. Unless you say you put the spring like this. And then I put the ball at the top. Like this, yes. You're acting the weight to the spring. Then your spring becomes shorter. This one, no. If horizontal, no. Horizontal is depend for the force I go to compress, not the weight of the ball. Now we want to find the elastic potential energy for the spring A. The question never provide the F. You don't using the mg is a weight. So now I need to apply the formula half K. Never using the F, using the K. Because K provided half K is a 200. Convert to meter. There's a 0.04. Square, don't forget the square. Final answer, okay?
我在算个笔啊 ，final answer 是 0.2 joule， 0.16 joule 才对，sorry。
16 joule. And the
算这
other
里
also fast. When I just mentioned, you type already. B, that means the maximum velocity. That means they want you to convert. So when I go to press the ball, I'm using elastic, is it? When I just release, what happened? The ball will move, is it? The ball move is a kinetic energy. So that means I assume no energy loss. I straightforward P. Elastic convert to the kinetic. I write the equation is a half x squared. Straightforward equal half mv squared. I need to find v. 0.16, we get it already just now. And half mass of the ball. Now it's correct. Mass of the ball. Mass of the ball now is how many gram? 10 gram. 10 gram, I need to convert become kg, 0.01. Then v squared. V squared, you know. You find the v, then square root. Anyone finish can type the answer in the chat room. 好了吗？打进去，没有人有反应。5.6569. 5.6569. Unit ms -1. Finish. Then we can see number 8. Number 8 is objective. Now you can see spring J hanging with the 40 gram. Then the figure show the 3 spring K, L, and M are arranged in parallel. Extend the same value, 跟它的长度我要一样as the spring J when they hung with the weight P. So 你认为这3个 spring 要 hang 多少才跟它一样的长度呢？肯定是乘3咯 because parallel 嘛。Normally the answer is 120. If I give you 120 gram, you divide by 3. That's everyone hanging 40 gram. From here, the answer is 120. Number 9, The spring constant K increase when 我要 K 上，怎样才能 K 上？Answer from Lim A B C. Which one is your answer? 我要很 strong 的 spring. 怎样可以很 strong 的 spring? A B C. Which one is a strong spring? 越长越 strong 咩？越长越 weak 的哦，短的才 strong 啊。The others, faster. C, diameter of the spring wire increases. Diameter 就是它的厚度，每一个 spring 的厚度越厚越难啦。C 啊 ，question last. This one question they want to catch you. Figure show the extension gains as they got same length, original length. 10 cm. Based on the graph, state the relationship between X and F. Because I got graph, I can straightforward to say exactly proportional to. Cannot write when because I got graph 有 graph 一定要写看不出来，除非是没有 graph 没有 graph 你就可以讲 when this one increase, that one what happened? What law? Hooke's law. What's the physical quantity represented by the gradient? Now the gradient is represent what? Is it the gradient represent spring constant? 是吗？我找 gradient 是我在找 spring constant 呢？
反过来的 spring constant.
Suppose is 1 over
1 over spring constant K.
Don't put K. Question don't care. The gradient now is 1 over spring constant. Now the question asks you, which one spring is most suitable to measure bigger force? Okay, I'm going to choose A or B. Which one can support bigger force? Not A already. Don't see the gradient already. No more gradient. The answer is B. Terbalik the gradient. The answer is B. Spring B. Then just show you, ask you why. Because the spring B is bigger. A smaller bigger gradient. Cannot say bigger gradient, not terbalik, is it? I need to write the answer is bigger of spring constant. You can say spring constant, you can say bigger of the smaller of the gradient. Smaller gradient. Smaller gradient means spring constant become bigger lah. Terbalik what? G equal 1 over spring constant. Spring constant bigger, the gradient smaller. Important is bigger spring constant. I choose spring, don't bigger gradient. Bigger gradient is wrong. It's smaller gradient. Because now the graph is terbalik. Take two factors. Why the extension of the spring A and B is a different? Can you give me the two factors? Length cannot mention already because the question says same length. You can say type of the material of the spring. You can say diameter of thickness. Diameter of the spring first. We can say diameter of spring. Diameter of spring means the coin. Coin bigger and smaller. This has a diameter of spring. Another one is the thickness of spring wire. Thickness means the thicker wire. And this has a two factor. Length cannot mention. Arrangement series, you can say series and also parallel. That one also is a factor. Only the length you cannot mention. F is an essay question. From here you can refer the pole. They want to jump. Elastic, like the pole normally is elastic. After that you jump, you go up. Gravitational potential. Here you fall down is a kinetic. Now we see the question what they need. Using appropriate physics concept. Explain the use of the suitable equipment and also the technique to improve his performance. From here, they ask you about the attire. Next one, the movement. Next, the pole use. How the pole to use and also safety. Our first step, we need to prepare the table form. Must have the table form, 2 columns. One, you just mentioned about the aspect. Reason. First one, attire, normally we need to type attire. Reason is reduce air resistance. This one is always for any athlete lah. I don't know, you are the runner or you are the jumper. Normally the attire must be tight because you want to reduce the air resistance. Number 2 is the movement. Movement must be fast lah. You must be, 对 attire 是衣服 your clothing 你穿的衣着 You don't mention what brand, no need brand, just mention there's a tight attire in a fit body. Movement must be high speed. You say high velocity. Move faster, is it? High velocity. Your reason is increase kinetic energy because you need to run. You cannot straightforward jump. You must run, baru you jump, is it? Okay, pole use. Normally we need elastic pole. Increase the inertia. Not related inertia. Inertia means you don't want to move. This one not related inertia. Inertia is no. You can say increase the momentum of inertia, no. Elastic pole. You increase elastic potential energy. Now you can see not enough. This one question only 8. So you need to double for the pole. I can say I'm using strong pole. Strong pole means long lasting, not easy break. You also can add low density pole. Low density pole, that means there's a lighter, easy to carry. This one is a pole. Last one, thick mattress. And you say thick mattress. Thick mattress, what's the function? Thick mattress means increase impact time, reduce impulsive force. This one is how we go to give the reason. From here, this one you see 1 until 4 only 8 marks. The pole you need to extra to give another explanation. Don't put the same one. From here, attire, normally we only got one. There's a type, or you say fit the body attire, reduce air resistance. The movement, you can say fast. You can say high velocity, high speed also can. The next one, you can say increase the acceleration, or you say acceleration enough. No need increase, accelerate. Or you say increase kinetic energy, increase momentum. Okay, no inertia, not related with the inertia. The pole, you can say elastic. Elastic, I can increase the elastic potential energy. Next one, strong pole. Okay, long lasting. Next one, low pole, low density pole. The pole is lighter, easy to carry. Don't put the easy behind. Carry easily. Don't put. Now they want to catch already. Put the easy in front. And the last one, safety. I want to using the thick mattress. And thick mattress, that means you can increase the impact time and the athlete just fall down and reduce the impulsive force. This one is the final answer. Actually, you put 5 enough already and no need to put more. Unless there's a question, section C. Section C, there's no limited. You want to put how many you just put. Normally put that 6, 7, 8, something enough already. For the section B, no. Follow instruction. Okay, maximum you put 5, then finish. 来，有问题吗？没有人回答，这样我就要问林思玉了。有问题吗？
蛮厉害，王老师，没有问题。
OK， 没有问题哈。接下去你们就要做的东西就是你看到那个 question 吗？
没有看到。
1、2、3，没有看到去看医生吧。
叫
1 until 4 you need to do inside the module exercise. One more thing is just now I told you the formative practice 1.3. 明白吗？ That means you when start the school, we already can start teaching already. So Monday you got class. Monday I want to see the answer for this problem solving. 4题的 spring 的，给我回答这4题问题。我给你答案 1.3 formative practice. OK， 就是这样。你不用抄题目的 formative practice， 直接我已经给你 photo set。没有的你就自己 photo set 啦。配进去你的那个 green book， 然后 after that give the answer 咯。Green book you can continue to use. 你空一面来做 index， 然后你就写那是 form 5的 ，OK 你重用。如果你要用新的，你喜欢OK somebody they buy so much they want to you finish it then you go to use OK anything? Remember this one module you put inside the file. For the student don't have one, better go to photostat already. If nothing to ask, this one record I will share in the Telegram group. You want to refer, then I'll refer back. If no, then we just stop here. Bye bye. Go to take your lunch.